Buddy, and welcome back to another video on my channel. Today we will be covering implicit differentiation, which is pretty much the last thing that we're gonna do before I show you a more complex example involving every single one of the rules we've covered so far, and we move on to the applications like related rates, optimization, concavity, and much more. And then we'll continue the calculus series on and on until we finish it, and of course we go on to a new series. But today is about implicit differentiation, which is basically finding the derivative when y isn't all on its own. Now, what is implicit differentiation? It's where you're differentiating implicit functions. So, explicit functions is like stuff like y is equal to f of x, where y is isolated. But implicit functions is equal to f, some function of x and y is equal to 0, where y and x, or x and y, are both mixed together. A few examples are x squared plus y squared is equal to 25, which is the equation for a circle, xy plus y squared is equal to 4, and sine x plus cosine y is equal to 1. What we will be solving in implicit differentiation is for dy by dx. Now, why do we need it? I already mentioned some of the stuff above, but let's continue on with that same topic. The first one is that some curves cannot really be written as y is equal to f of x. Basically like the circle, where you'll have to have two curves of y and x for the plus and the minus. Then, sometimes it's difficult or even impossible to solve for y explicitly, but implicit differentiation gives us a way to find dy by dx without having to isolate y and go through all the hassle. Now, it's also useful for analyzing relationships between multiple variables where we're differentiating multiple variables, and multiple variables will come in very handy in Calculus 3 or multivariable calculus, which will most likely be the series right after this one. Now, the reason I waited this long to cover this is number one, normally it is taught much later, and I agree with that fact, and number two, the way we really do it must come after we've covered the chain rule. So, if we differentiate y, which is a function of x, with respect to x, we get d by dx of y is equal to dy by dx. So, when y is a function of x, using the chain rule, we're going to get 2y times dy by dx. So basically, treat y as just any function of x. So when we have stuff like y squared or sine of y, we're going to be using the chain rule. And the chain rule is going to be something very commonly used, so you must have a very solid understanding of that. And it might also help to be able to do a little bit of it mentally to start speeding up your ability to solve the problem. Now, before we move on to the examples, let me show you a quick step-by-step process to figure out dy by dx from an implicit function. The first is to differentiate both sides with respect to x. The second is to apply the chain rule when differentiating terms with y, basically doing the stuff we mentioned above, where we keep y as a function of x, so it'll be whatever the derivative of the outside function is. So if it was y squared, it would be 2y, then multiplied by the derivative of y with respect to x, or dy by dx. The third step is to collect all dy by dx term on one side. The fourth step is to factor it out, and the fifth step is to solve it. Now, steps 3, 4, and 5 all kind of interlink, which is basically just factoring and solving for dy by dx using algebra. So, let's move on to the examples. Now, our first example is to find the derivative of y with respect to x for x squared plus y squared is equal to 25. The first thing that we need to do is do d by dx of everything. So d by dx of x squared is equal to 2x. Then, using the power rule, plus, now the derivative of y squared with respect to x would first be 2y, differentiating the outer function. Then we would have dy by dx, because that's what we do pretty much when we differentiate the inner function using the chain rule. Now, the derivative of 25, since it's a constant, is equal to 0. Then, the next step is we have to factor out 2 to make this slightly simpler. So, we have x plus y multiplied by dy by dx, which is equal to 0, since if we divide all the sides by 2, 0 divided by 2 is still equal to 0. Then, the final step, or the final few steps, will be to factor out dy by dx and solve for dy by dx. So, if we bring the x term, which doesn't have dy by dx, to the other side, we get y times dy by dx. Then, after that, we have dy by dx is equal to negative x. Now, since we have dy by dx on one side, we can factor it out, which is pretty much already factored out since there's only one term with dy by dx, and divide both sides by y to find that dy by dx is equal to negative x divided by y. And there you have it, our first example pretty much all solved, all completed using all these steps. So that's pretty much it. That's all we're going to be using this for. So that's a pretty simple example. Now it can get much more complicated if we add double derivatives, more examples of the chain rules, the product rule, the quotient rule, etc., etc. It can get very complicated, and that's pretty much what my next video is going to be about. Combining all of these rules and solving for one singular example. Now you might be like, oh, how hard can it be? And you're actually kind of right. It's not very difficult, but it's very tedious and can take a long time, and is in fact very easy to make mistakes since there's going to be so many steps. And here is the solution slide. The solution is exactly what I mentioned above. Now the thing is, what's going to happen from now on, I realized that if I really want to have you guys just check the solution instead of you guys randomly looking around, I'll leave the timestamps for each of these slides when I cover them in the description or in a pinned comment, so it's very easy for all of you to just figure it out. If you're already doing it before me, then just go and check your answer in the solution without having to fiddle around too much. Our next example is to solve dy by dx for xy plus y squared is equal to 4. So what we're going to do is pretty simple, except for one major twist, or not really a twist, but one key difference between this and the last example. If you see over here the xy term, we'll have to use the product rule for that, since it's one function of x times another function of x. We're going to start with differentiating the first term. So what's going to happen is we have the derivative of the first term times the second term, so that'll be 1 times y, plus the first term, which is x, times the derivative of the second term, which using the chain rule is dy by dx. Now, it could also be the first term times the derivative of the second term plus the second term times the derivative of the first term, since it's just since it's the product rule, everything is positive, so you can switch them around without any difference to your answer. Now, the next term is y squared, which we already covered in the last example. The derivative for that is 2y multiplied by dy by dx. Now the derivative of 4 is equal to 0 since that's a constant. Now the next step would be to start simplifying and bringing all the dy by dx terms to one side, or bringing all the other terms to the other side. So what's going to happen is if we have x times dy by dx plus 2y times dy by dx is equal to negative y, since we brought it to the other side. Since we brought this term, it was just highlighted to the other side. Now, what happens after is pretty simple. All we have to do is factor out dy by dx. So we have dy by dx multiplied by x plus 2y is equal to negative y. Since we have dy by dx all factored out, the next step, or the final step, would be pretty much, final step here would be to divide everything by x plus 2y. So dy by dx, it's all the way on the right. It's a little hard to see, then I'm sorry about that, but it should be okay. Dy by dx is equal to minus y divided by x plus 2y. And there you have it, our second example all completed. Dy by dx is equal to negative y divided by x plus 2y. And over here is the solution, where we have differentiating both sides, then collect and factor the dy by dx terms. And as I explained in the first example, from now on I'll be leaving the timestamps to all the solution slides in the pinned comment or in the description, most likely in the description, but I might also do it in a comment, just so you guys don't have to fiddle around and find these slides if you finish the problem before me. Our final problem is to find dy by dx for x squared minus xy plus y squared is equal to 7. So what it is we have the xy term over there, but also we have a few extra terms that will make this slightly longer, but in no way more complicated. So let's start differentiating from side to side. On the very left, we have the x squared, where the derivative of that is simply 2x, then minus the derivative of xy, which we figured out above, is 1 times y, plus x times dy by dx, and it's really simple, all for xy, and plus y squared, which we also figured out earlier due to the chain rule, was 2y times dy by dx. And this is equal to the derivative of 7, but since 7 is a constant, it's equal to 0. Now, let's start by first expanding this equation and bringing all the dy by dx terms to one side, which will be the left side for us. So the next thing we need to do is expand this equation and pretty much get rid of these brackets. So we have 2x minus y minus x multiplied by dy by dx. After that, we have 2x minus y minus x times dy by dx plus 2y times dy by dx. And that's pretty much the first part of our example. Then the next part will be to simplify everything. So what we have here is we have 2 dy by dx terms, but what is missing is we having them all on the same side. So if we bring the 2x and the negative y to the other side, we get 2y times dy by dx minus x times dy by dx. Then after that, what we have is on the other side, we have y minus 2x. Now, the next thing we need to do is factor out dy by dx. So we have dy by dx, multiplied by 2y minus x is equal to y minus 2x. After that, all we need to do is divide both sides by 2y minus x, and we get our answer, which for this problem is equal to, firstly we have y minus 2x all divided by 2y minus x. Now, as you see, it's not very complicated now. I already said it can get more complicated later, but the basic principle always stays the same. Apply the rules in the order they need to be applied, do all the algebra work, double check your work to make sure you didn't make any mistakes, and voila, there you go, and you have your answer. And over here, we have also everything over here. Now, you might wonder why it says 2x minus y divided by x minus 2y. Now, the reason for this is all I did here was just multiply by -1 for the numerator and the denominator, but the answer is the exact same. So if you either got 2x minus y divided by x minus 2y, or y minus 2x divided by 2y minus x, either way, you're completely correct, and you did nothing wrong. Now, before I go, I wanted to give you a few practice problems and the solutions to these on the right. So, the first practice problem is x squared plus 4y squared is equal to 16. The second is x cubed plus y cubed is equal to 8. And the third is 2xy, minus y squared is equal to 3. And the answers are all on the right. Now, be sure to ask any questions or anything about these practice problems in the comments, and I'll be happy to answer them. And thank you so much for watching these videos. I really appreciate it if you watched it all the way to the end, or if you just watched it anytime at all. If you found my content educational and you enjoy it, please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. And also, don't forget to comment down below any tips, suggestions, questions. I'll be happy to answer most questions, and I'll definitely try and fulfill my word on most suggestions or tips for the channel, because my goal is to make it as good as I can for all of you. So, thank you so much. See you in the next one, and bye-bye.